This is my self-balancing robot. Designed many self-balancing robots. So we'll learn to construct this robot using how many accessories or type of accessories required, and also we'll learn how to fine-tune it and fine-tune using hardware adjustment and using the software adjustments. So let's learn it and see how it is designed, constructed, and fine-tuned. Okay, hello again. So let's go ahead. As I said, already have given the demonstration of the self-balancing robot. So in this video, the next part of the video, we'll learn how to design and construct the robot and also fine-tune. So let's start with the accessories required, how they are placed and designed and construct and rebalanced and retuned it. So these are the two DC motor. I'll go through the accessories and I'll also explain the reason behind selection of the accessories, DC gear motor and all those things. So this is 250 RPM DC gear motor. You can select a DC gear motor starting from 200 to 300 RPM, because what I have seen is that any self-balancing robot, they works very good and easy to balance and fine-tune it if their RPM selection of the DC gear motor is between 200 to 300 RPM. I tried with 100 also. 100 works very good, but when you push it, they fall immediately because the reaction is very slow and they fall. And if you select a higher RPM, the torque is less, so they may fall again, and there will be a lot of volatility in the movements. So this is the reason behind selection of 200 and 300 RPM. So try with 200, 250 and 300 and see which one works, and also keep trying with different torque of the DC gear motor. I have used this rubberized 60 mm wheel. So try with even a direct plastic wheel, see if it works, but these are the two suggestions for the wheels. Now let's come to the label, how many labels we can have in this. There is no particular choice here, but putting 3 labels makes a good sense, because in the first layer you can put a driver, and if the size of the body is, this is very less actually, this is really less. So size of the, depending on the size of the width of the body, you can, I'll say this is a width for me, so don't ignore this part. So first part you can put the Arduino, or you can put driver, and the top most part you can put the sensor GY521. This is used for tracking the motion of the body, the robot, the way it moves. And the lithium ion battery, it's little bit heavier, 11 volt, you can say 12 volt. So that you can put in the uppermost. You can attach to the top of the head, or you can place in depending on how you fine tune it, able to move it. Okay, so this is what the things and how they are done. So now let's consider the part which is placement of the things around the body. So what I have seen is, if you consider this as the axis, then it's better to redistribute the weight across the body. It should be towards the axis, near the axis, and they are not scattered, but they are uniformly distributed. So if during the balancing part, if you see with the default parameter, without fine-tuned part of the loading the code, if you see there is a little bit of movement here and there, then try to redistribute the weight, not disturb too much, and see if the movement is smoothened. And after that you go and fine-tune with PID parameter. P start with 15, start with 10, 12 sometime, and go up to 17, 18, 21 also. Then I is there, and the D is there. D is less. I is little bit higher, actually higher than starts with 85 and goes up to 110 or something. So using those variation, you try to balance. So first you always start with P, because that makes huge difference, because that will tell you the robot is standing upright, and it's able to move, stand a little bit, a fraction of second, or so 10 second or maybe 5 second. If it does, then you rebalance PI, and then you move D. You can start with the optimum parameter for all this thing and then do it. So this is what it is. Another thing is that sometimes you see when sometimes it's able to balance, but it moves too fast in any one direction. So what you can do is you can minimize the maximum PWM parameter of the robot. Uh, During the calculation process, when you get a high PWM, you should set the maximum, like instead of 255, limit it to 220 or 200 in that way, and see how the movement is. If the movement is smoothing, then you make sure, then you realize that okay, this is the optimum, and see if it push it. If the reaction is very slow, then you increase the PWM default upper limit. So this is the we do. Sometimes what happens is when the movement is too low, it may fall. So for that, what you do is you set a default minimum PWM value like 20 or maybe 30 or something, sometimes minus also. I mean, not really minus, but this is a way you have to adjust it. You have to set maximum PWM and minimum PWM. So that is the way you make sure that it doesn't fall if it is too slow, or it doesn't move too fast if you push it or you move too fast in one direction or this direction or that direction. So as you can see, we have learned what are the accessories required. It's very minimal accessory, GUI 521. This is a driver. You can use any driver that support PWM manipulation also. It should be a braking power as well as PWM setup and directional settings of the motor. You need 12 volt lithium ion battery and a Arduino board. Any type of Arduino board should work here. And DC gear motor between 200 to 300 RPM. So this is the things, and we learn how to place the stuff around the robot part, and how to redistribute the accessories and set up and fix them across the axis, spread uniformly across all the labels. So and then we have learned how to minimize the volatility in the movement by fine-tuning the PID parameters, as well as by setting the lower and upper limit for PWM value that is passed to the DC gear motor. So this is the way we do it. Another thing what I have seen is setting up the initial things also matter. What happens is when you do it, try to stand it up in a way, actually it sometimes stand in a very, not in a very upright vertical, it moves in one direction, inclined to the vertical axis. For that, what you do is you make this GY 521. If you can see this GY 521, you make it little bit movable so that you adjust it with x axis or y axis, whichever you're using for balancing, and depending on that adjustment, it will stand in upright position. So don't fix it. Instead of fix it and go and change in the program, you do it mechanically here, and this parameter will be passed to the program, and that will take care of the balancing and standing in the upright position. So this is the way you can balance it. Another thing is that if the connection should be very fixed and tight, so that it is not getting loose, and sometimes it may give a spark or something and may fall actually. So for that, you make sure that it's tight and unnecessary wires are removed. That you can do over a time. So this is the way you design, construct and fine-tune the robot. So hope you like this, and thank you very much for watching this video. If you like it, give a thumbs up. Bye bye.